Okay, students, we are near the code execution in the last class. Until here, I have told. Um, okay, so I was explaining what is the code execution at the client side. So basically, it is that you are trying to run something and the in the client side only. So when a client is downloading any application, along with that, the client side code is also getting downloaded at the client side only. For example, Google Maps. So what happens? It is rendering at the client side only, right? It is basically the scripts will be running at the client side so that it will take less time or to execute or something like that changes. Something that it will happen. It is taking less time because it doesn't want to go to, does not has to go to the server side and get executed and return the data, but instead the execution will happen at the client side only. So basically, in the Node.js or JavaScript related applications, we can run the code on the client side only in the web application or inside the application. So that's what it is. Next, there are some disadvantages. For that, the browser or some application dependency should be there, and and also like the time will take because it has to transfer um, it has to transfer from server to client. But in the client side, what happens since it is executing at the client side only, it takes less time, but it has to store more amount of data. So initially, it takes much amount of space, like to store the client side related so it has to store that amount, that large amount of client-side code base, which has to be rendered. So that's why it takes more time to like loading the application in the start. Okay. So next concept is Puppet Master and agents. So this is also one of the deployment tool. Here, the Puppet will work in the way of a master and the agents, where it is following a client and server architecture. So what happens here is there are two components. One is the Puppet master and second is the Puppet agents here. So what happens here? Um, we are basically how this will work as in the form of hub we have seen in the computer networks also, like there will be one central system and there will be nodes which are attached to this central system, right? So in the same way, this Puppet master is working as a central controller in the system that is responsible for making configurations and distributing them to the other clients or the nodes which are attached to this Puppet master. So basically, these agents are attached to the master, and these are uh, getting the instructions from the master. So what the master is doing is it is sending the or managing the configurations or distributing to the agent. Agent is basically getting the configuration or other instructions from the Puppet master, and it is applying to the respective systems. So whatever the nodes or whatever the systems it is attached to, this Puppet agents are doing in that way. What is this Puppet master doing basically? It is a central configuration type, like it is storing all the required configurations inside it, and whatever it is storing and it is compiling, right? So it doesn't directly execute the task, but coordinate and oversees the process. My means like what happens is whatever the task are there, this Puppet master is not directly executing them, but it is basically it is coordinating, like it is distributing the task to the Puppet agents. So Puppet masters holds manifestation. Like what we have seen in the fourth unit is basically everything deployment related. Most of the things, like if you see Jenkins or Docker, everything will have the configurations files within them, and in seeing them, like even if you see Kubernetes also, it has YAML files. So what it is having some configuration detail, or something like it has to follow some steps to do or perform some task. Similarly, this Puppet also, it is also one of the deployment tool. So it is also holding some configuration files. And based on the request from the Puppet agent, the Puppet master creates a catalog that is the list of resources that need to be configured on the agent machine. So what happens that this Puppet agent first, it will send the request to the Puppet master. So then Puppet master will actually configure whatever the required resources for the Puppet agents. It will store in the form of a catalog, like what resources are required, related to files or whatever the services that has to be done. Now, once these are compiled, the catalog, whatever this it is maintaining or it is creating by the Puppet master, it will be sent to the Puppet agents for the execution. Now it allows system administrators to manage infrastructure from single point, ensuring consistency across all the machines. So this Puppet Master is not only maintaining on its own, like it is also a control center for configuration, but it is allowing some system administrator, some like we can able to manage the infrastructure, so that we can maintain consistency across all the machines. Puppet Master communicates with Puppet agents across over a secure HTTPS connection. So, connection like we can communicate either so request or the responses that can happen through either HTTP or HTTPS. So, using the secured HTTPS connection, this master will be communicating with the agents and sending compiled catalogs. So, what are these catalogs containing? The resources, right? The files or the services, everything. So, this Puppet Master will be sending that compiled catalogs with the agents, and after getting that, agents will report back to the master what status it has basically. Now, what is this Puppet agents doing? They are getting installed on individual machines like nodes, and that has to be managed. So they are the clients in this setup and handle executing the configuration on each system. So um, this puppet master is not performing the task, but it is handling this resources, how much it has to configure. It will configure on this individual agent machines, and this agent machine is basically handling the things like it has to be installed on the individual nodes or server machines, and these clients in the setup can and handle executing the configuration on each system. Periodically, a Puppet agent contacts the Puppet master to request the latest configuration. So, this Puppet agent will normally contact the Puppet master. Okay, so it will request for the configuration at first. So at first, what is happening? Agent is contacting the master for configuration. Then configuration is sent from the master to catalog in like master to agent as in the form of a catalog. So first agent is contacting to master. It is requesting for some configuration. Then master is sending that configuration back to the agent in the form of a catalog. So then the agent will apply the required changes to the system, such as installing software, modifying files, restarting services. all these things are sent by the master to agent to do this installation and all to the agent. Okay. After configuration is applied, so agent request, then the master will send those configuration details. Then agent will install those things or perform those actions. And after this configuration is applied, the Puppet agent reports back to master informing that is there any issues, if any issues are present further or any changes are there further. Okay. So agents initiate communication with the master requesting configuration updates. Then the agents will check in regularly for every 30 minutes, but can be manually triggered to request an update as needed. So what happens, like every 30 minutes the master will be checking like am I getting any request from the agents. So if it is not getting like or else you can also do manually check like if you are getting any request from the agents. If it is getting any request from the agent, the master will be sending that appropriate configuration catalog to agent. Okay agent, you do this thing, so you install this software and or you do modification of these files and all, this agent will be sending to that master as per request. So then the agent, according to that, the agent will uh, perform those tasks as master is done, master is sent, and it will report back to master. This is how they will work. So how are the advantages present here? Is it is a centralized system, right? As I have mentioned earlier, there is some server like a central system is present, and there is like other things like other systems are present like puppet agents are also present. The puppet master can manage hundred or even thousands of nodes. Puppet can master can have many nodes attached to it, means many agents can attach to it. Okay. So here it is a single point to manage all configurations. Puppet automates configuration, reducing the need for manual intervention and making infrastructure manageable, management scalable. So it is what it is doing is it is actually reducing the manual intervention. Uh, Automatically it can update the configuration as per the requirement. Instead of we going there and actually changing the configuration and all. So that is what it is doing. Now the Puppet agents run configuration tasks locally, reducing the time on uh, Puppet master and allowing faster application of configuration. So there are different nodes. Okay. Then all those different nodes configuration, if we have to run on one single master, it takes more time for the application configuration updation. So if you see any application, there can be a parts like a front end, back end, and database related and all. So at least these things will be present. So when you are executing configuration updations, that can happen for either front end or that can happen for either back end or anything else in the application. Now, if you want to change configuration for all the parts of application at a time on a central server, imagine it will take more time. Otherwise, if you are executing like parallelly, independently, same task but with the two, three other things, okay? Seems like one person can't do three multiple things at a time. If it is divided between three people, they can perform parallelly those individual tasks and they can complete in a faster pace. So, in the same way, this completes. Okay. So with Puppet, you can define a desired state for all your system. For example, what is desired state? So a system needs to be run with one single server, or I should have multiple instances of same server. So like this, like if I want like a more number of instances that has to be run for that application. So to define that desired state, we can run according to that configuration, we can execute. Okay. Regardless, they maintain consistent regardless of any changes or additions to the infrastructure. Similarly, there is another tool which is Ansible. That is also one open source automation tool. As you have seen, like one of the automation tool is Jenkins, which is also open source. This Ansible is also open source, and it has its own abilities or configuration related things. So this Ansible is used to simplify IT management tasks such as configuring systems, deploying applications, and automating workflows. So when you are configure to actually reduce the manual things like configuring a system, you need to go and update any file on your own. Instead of that, you can actually automate it, right? And it allows system administrators to automate repetitive actions, streamlining operations and ensuring that configurations are consistent and scalable across entire infrastructure. So the system administrators also they can automate all these actions, whatever present in the above. And Ansible operates by connecting remote machines via SSH. So SSH is also one protocol which you would be seeing in some, for example, if I want to, okay, so we are here, right? Huh. For example, if I show this putty and I want to connect to the remote machine, this is my remote machine, for example. Remote machine means same like my machine only, it is running on the cloud with the same storage, CPU, all those things. Okay. And on the cloud. So when I want to connect what I'm doing, I am connecting with SSH, right? So I will load this first and I want to open this. What happens in the whole in this place, I will mention like this is the host I want to open and this is the port. Generally, we connect to remote machines using SSH connection and the port will be 22. So what happens? It is trying to connect to my virtual machine. Okay. I'll accept the certificate, login, and it is asking for the password. So this is my password. Here I type password. See. Now this acts like same my Windows only. Um, I can go to any directory. I can see that there are some files here. So this is my virtual machine. I am connecting this with from my local system to that virtual machine using the SSH protocol, right? So that's what it is. One example. Now, in the same way, you can take this Ansible is actually connecting to remote machines using SSH or Windows RM. This is one tool, as you can see for executing predefined tasks to configure and manage those systems. This is agentless. This means that it connects system directly via SSH, eliminating need of additional software and on the target machines. As we have seen in Puppets, there are some requirements like we have to mention a configuration file and we have to install some things in order to connect to target machines. But here we need not to do that in Ansible. We can just connect via the SSH connection. Now Ansible is agentless. This means it connects to system directly via SSH. eliminating the need for additional software on the target machines. So we need not to direct, like we can directly, if we are able to connect to that particular machine, what is the need of additionally installing the software, right? So that's what like Ansible is doing, and it is following a declarative model where you describe the desired state of a system rather than specifying exact steps. You tell Ansible what you want, and it ensures the system will reach that state. So what happens here? Instead of specifying what steps it has to do, you will be describing the state of the system, what you want, and in that desired state, you will tell your this is my desired state. Like finally, I want um, okay. So for example, finally, I want this many number of containers to be running in my system. That thing you will be mentioning like how many containers you want or how many instances of application you want to run, what is the scale of the application, like all these things you are mentioning only the target of system you want and ensuring that whether your system is reaching that state. Okay. Ansible uses modules to carry out tasks on target machines. Modules perform specific operations such as installing software, um, managing services, modifying files, etc. Ansible provides many built-in modules, but you can also create custom ones when necessary. So, using the how it is carrying all these tasks, all these operations, it is basically using the modules. Okay. So this is one. Example, like a playbook is written to define desired actions. A playbook might specify a specific package should be installed or a service should be started on target machine. Running this playbook, Ansible makes these tasks are executed in correct order. So same like configuration files, there will be one playbook. Using this playbook, this Ansible will be getting to know, okay, these are the things which I have to install or services which I have to start on the machines. So this in this way, basically all deployment models will be running based on some configuration files. One of the biggest benefits of Ansible is its idempotent nature. This means running the same playbook multiple times on same system won't cause the unintended changes or errors. I hope you understood. And I have also written like what are the advantages of this. It doesn't need any agents like puppets, and it is just making use of playbooks which are easy to understand, and non-technical users also they can use this. And learning curve and improves the team collaboration. Like learning curve means like need not to learn more things. Like it is easy to understand and it's human readable. Ansible works well in variety of environments, whether managing on-premises infrastructure, cloud-based system, or hybrid environments. With Ansible, you can automate virtually every aspect of system configuration. Um, basically, uh, you can manage or you can most of the things of the manual work you can reduce using the Ansible. Okay, so here we are with the chef concept, and if we complete this chef concept and salt stack, um, that will be our last few concepts. So, so here the chef is like open source automation tool. It's also working same like the puppet. So that's why I'll be so that's why I have covered it like in a way that you understand. If you understand that puppet thing, you can write easily about the chef also. And this is basically having components same like Puppet master and agents, the chef server and the client. So this chef server is acting like central repo and it is maintaining all the configurations. There what happened, it is also maintaining some, like Puppets are requesting some files and that master is giving back to those configuration whatever needed those things it will be giving back to the agents. Same way in this also server is acting like central repo and it is maintaining configuration in the form of cookbooks, recipes and metadata for each node in the infrastructure. So Chef client is installed on the machine that you want to manage. It communicates with the Chef server to retrieve and apply configurations on the node, ensuring stays in the desired state. So here also there in the Puppet agents how it is getting installed on the desired machine. Same way here client is installed on each machine that you want to manage, and it communicates with the server and retrieve and apply the same concept with different names as you can see. Chef Workstation is where administrators develop, test, manage cookbooks and recipes. Same like system administrators are there to manage the puppets. Here also administrators will do the same thing. That they will manage those configuration files as in the name of chef cookbooks or recipes, whatever they call. But those are the configuration files which are maintained by administrators. So it provides an environment where you can create automation scripts and configurations for nodes. Cookbooks are primary unit of configuration in Chef. What are these cookbooks? They are like the configuration files in the Chef, and they contain recipes which are defined as the actions. So that has to be performed on the nodes, such as installing packages, modifying system or settings, etc. So these cookbooks can include templates or like whatever the components, configurations related things are present as a recipes. Like the name is like that, but you can take it as a configurations. Okay. So what are these recipes or the configurations? That is the desired state of the system, where we are specifying like which actions has to be which actions has to be taken on each node, such as installing software or managing services, etc. So recipes are written in Ruby basically and allowing configurations which are complex also. So here workstation is used for writing cookbooks by the administrators and the recipes are pushed to the that means configuration details are pushed to the server which is storing them for acts and then the nodes which are chef nodes will be there. So those can that means chef clients those can access the chef server and fetch those configuration which these chef clients will be installed on the nodes which are target machines and those can actually fetch those configurations and apply them to local system. We generally use chef for scalability flexibility in the large ecosystem because Chef automates complex configurations across many systems. It has wealth of pre-built cookbooks because it is so they are automating many complex configurations. Okay, so that's why these it has a wealth of pre-built cookbooks and sources available through its active community. Now, if you see the Salt Stack, what is the Salt Stack? It is also open source, means everyone can use this automation platform. It is also designed to manage configuration systems. Now, it provides features for infrastructure automation, configuration management, and orchestration, making it ideal for large scale deployment. Now, this alter stack is following different components. It is also same like Chef Master and client. We have the cookbooks concept. The names are different, applications are different. but the same way they work. Okay, the same way they work like SaltStack, Chef, as well as the Puppet. All the concept is same, and their intention like same, like to deploy the application or automate the things. And they have a similar concept only. Like here also we have Salt Master is the central server which is managing or responsible to manage all the configuration needed for the nodes. So here also like different names. These are called master is the salt master is central server here. And the nodes are like in the central ecosystem, there will be children like one central server is called master and the other or managed nodes are called minions. So it controls overall orchestration and automation task. Now salt minions are the target systems which are managed by this salt master. This salt master is giving commands and executing the task. It's actually master is giving commands to the minions, and this is listening to that master, and it is executing whatever it is. Its master it's giving the commands, as in such a way like applying the configurations and installing packages, etc. So these state files in Salt are written in the YAML file. So again, YAML is also like JavaScript or sorry, JSON or XML. It is also one of the language basically used for defining the configurations. YAML you would have encountered in Kubernetes as well. So they describe the desired state of the machine, which packages should be installed or which services should be running, etc. State files are comparable to chef's recipes. So and these are also similar to the chef's recipes, like configuration details, which I have already told. So, execution modules perform the actual task on minions. For example, installing a package, restarting a service, or modifying a file. So, all these are like different tasks which it can perform that can be invoked from master to the minions. Now, how it will work? Master is sending some configuration commands to minions. So basically, it is the central server is sending some commands to the other nodes, which are minions, and these are listening to that master and executing those commands, ensuring that the system is meeting the desired state. Now, Salt allows the real-time communication between this master and minions, ensuring some faster a little bit it will be faster, okay, and task that can be performed on the minions. So minions can be of many like target systems, so that master can enable like this salt will allow a real-time communication between that central repo to the minions. Now, what are the advantages? It is basically fast because it is real time. So all deployment related applications will be same working strategy, but some or other difference will be there, right? So if you see, so here if you see like it is ensuring some fast real-time execution between the nodes and multiple nodes and the master, and it can efficiently manage large infrastructure of the systems with the minimum overhead that can support both push and pull models for executing configurations, providing flexibility in how tasks are applied. So it can sir, push and pull models means what? That either the minions can able to push the changes to the master, or the master system can send from the master system it can get the configuration details like using the pull operations. Okay. So while we can see some differences, okay, there are some different deployment applications like Chef and Salt Stack, but majorly there will be some or other difference between them, right? It's like a client server model, Chef, and it has workstation. Chef server will be there, and Chef workstation for administration purposes, like how they can change administrator can able to change for the systems desired the state, the chef server we have seen, and chef clients, which are interacting together to automate the task. And where Salt Stack is following master minion model, where Salt Master manages the minions and sends the commands to execute. Chef is operating pull model only. Okay, only clients can able to pull the changes, but they can't push the changes to central repository. But here in the Salt stack, it is working like a Git model. It is able to push the changes. Also, it can able to pull the changes. Pull means from the central to itself. It can take the changes, or else it can push the changes to the central repository. But as part of performance, SaltStack is known for its speed, and so because it is ensuring the real-time communication between the central repo and the target systems, so it is ensuring the speed, okay, in executing commands across multiple systems quickly. Whereas Chef is slower because compared to SaltStack when managing in large number of applications due to its configuration process. So it is having some complex configuration process. As part of learning also, SaltStack is easy to learn because YAML, but Chef is using Ruby. Okay, YAML will be like same like a normal text file only, and there you will be mentioning like column. Okay, if you see like sample YAML file, um, so sample YAML file, how it will be looking. See, just like colon something, and it is like list. Okay, this format is list. This format is like key value pair. Same like this only it will be. This is the YAML file. Okay. So it is very easy, but if you see Ruby, right, it is one language. It is difficult to learn, right? So learn and apply. So learning curve is there in the chef, but Salt Stack is very easy to learn and apply. Now, therefore, we can say both Chef and Stars also both are powerful only for automating the infrastructure management and other capabilities. But Chef is ideal for complicated environments, whereas for scalability things and in order to apply easily or to execute it fast and real time when we need like important task will be there in the large infrastructures, those things we can choose any of the. So like everything will have its own advantage. So which one you have to choose, that according to your requirement of the application, you can choose any one of these deployment strategies.